Today I want to show you how I built a simple line-following robot using an Arduino Uno and TCRT5000 sensors. To make this robot, I've prepared all the necessary components. First, there's an acrylic chassis. It already has 2 geared motors attached, along with the wheels. I've also installed a battery holder for 2 18650 batteries. At the back, there's a caster wheel that helps the robot turn more easily. Finally, there's a power switch mounted on the chassis and connected to the battery holder with 2 small wires. Next is the Arduino Uno board. This board will control the operation of the robot. I also use an L298N motor driver module to control the 2 motors. This module can also provide a 5-volt output if the input voltage is below 12 volts. I'll use this 5-volt output to power the Arduino Uno. For sensors, I'm using a 5-channel TCRT5000 sensor module. This module has 5 TCRT5000 sensors and helps the robot detect and follow the line. The final component is 2 18650 batteries to power the entire system. To connect everything together, I use jumper wires. These wires are very convenient for prototyping. Since the line sensor module needs to be placed close to the ground to work properly, I designed and 3D printed a mount to attach it to the robot. This mount improves accuracy and also positions the sensor slightly forward, making it easier to fine-tune the robot's performance. Now I'll start assembling and connecting all the components into a complete line-following robot. First, I mount the Arduino Uno. Next, the motor driver module. Then the sensor mount and the line-following sensor. All components are now attached to the chassis. Next, I'll connect them together using jumper wires. First, I route the power wires from the bottom to the top. The red wire is the positive terminal and connects to the 12-volt input. While the black wire connects to GND. Then I connect the 5-volt output of the L298N module to the VIN pin of the Arduino and GND to GND. Next, I connect the 2 motors to the OUT1, OUT2, OUT3, and OUT4 terminals of the L298N. The motor wires can be swapped if the motor spins in the wrong direction. Now I connect the L298N module to the Arduino Uno. ENA goes to pin 9, ENB to pin 10, IN1 to pin 8, IN2 to pin 7, IN3 to pin 12, and I N4 to pin 13. Next is the sensor module. I power it using the Arduino. The 5-volt pin of the sensor connects to the 5-volt pin on the Arduino, and GND to GND. The output pins OUT1 to OUT5 connect to pins 2, 3, 4, 5, and 6 on the Arduino. At this point, all the connections are complete. I'll insert the batteries and move on to writing the code. Here is the code I wrote to control the line-following robot. First, I define the connections to the L298N motor driver. Then I define the connections to the sensor module. Next are the motor speed parameters, followed by the PID parameters. The setup function is straightforward. It just configures the pin modes for inputs and outputs. The rest of the code implements a basic PID controller so the robot can follow a black line on the floor. I'll leave the code in the description so you can use it. After uploading the code, you can tune the PID parameters to match your actual setup. And here is the final result.